The methods of error detection. The methods of error detection. Up right here, we will be discussing that what are some certain ways how you can detect some errors. In this, we will be discussing some number of ways and approaches to detect errors. But to detect errors in which of the areas, that means that if I want to detect errors in data transmission. For example, if the data is being transferred from your A computer to B computer, then how are you going to detect that if there are any number of errors or not? So this is what we are going to discuss this, but even before that, I first want to make it clear to all of you that why there is a need to check for errors. Why there is a need to check for errors, or even you can say that what are the reasons that why there is a need that I need some error checking method. So first of all, the point is that when your data is being transmitted, when your data is being transmitted, means your data is being sent from computer A to computer B, which means your data is being sent from one place to another. So there is always a need to check for errors because there can be various examples, right? Like for example, your data can be corrupted, your data can be lost, or even your data can be gained as well. So these are some of the reasons that why do there is a need for error detection methods, or I can say that during during transmission, that means that if your data is being sent from one place to another, so the point is that there can be three examples of that, three examples, right? Like for example, an error can be caused if there is any sort of interference. Just a moment, let the azan complete. Okay, so as I was discussing with you that the methods of error detection, I need these error detection methods, or these are some number of ways in which I need to identify that if I am sending data from A to B, if I'm sending data from one place to another, so how can I detect errors? The reason is that when your data is being transmitted from A to B, there can be problems if your data is corrupted, if your data is lost, or if your data is gained. So during transmission, there are three problems that can occur. First of all, the first problem is interferences. Interferences can be an electrical interference as well, or any interference caused by weather, due to weather conditions as well, that might impact on the cables or on the wire, so that your data may be corrupted, lost, or gained. You need to understand that, for example, if I have a data that is of 10 MB, so when the data is being transmitted from one place to another, just as it receives this end, it's supposed to be 10 MB. This means that that is how your data is accurately transmitted. But just in case if your data is of 10 MB, and after receiving on the destination it becomes 12 MB, or just in case if your data is 10 MB and just after receiving it becomes 9 MB. So you need to understand that even if the data is gained, or even if the data is lost, it will result in corruption. So that would means that my data is not accurately received, it has some problems. So during transmission there are three number of ways. There can be an interference as well. Problems can arrive during packet switching. I think we have not discussed packet switching. Have we discussed it? No, we have not. I will be discussing packet switching with you. Then we will be going through that. The third area is that skewing of data. That means that if your data bits are being arrived unsynchronized form into an out of an order form, so this can basically cause errors. So are you all clear till here that why there is a need of error checking methods?
Yes, sir.
Yes.
Checking for errors is basically more important so that you can know that your data is there or not. So there can be some number of ways to check your data, and the number of ways are right here. Ways to check for your errors. So the first way is right here. That is basically a parity check. First of all, I'm going to discuss with you that how can you check the errors if you have parity checks. This is the first way that we will be discussing if there is any sort of error into your computer. So first of all, if there is a question into your exam for parity check, you can definitely write that parity check is one of the method to check if the data has been changed or corrupted following the data transmission. So this is the first line. That means that it is used to check that if your data is being sent from one place to another, is it accurate or not? Is it correct or not? So that means that if I'm sending my data from A to B, it is used to make sure that if the data is correctly received or not. So basically, a parity check is based on two of the categories. A parity check is based on two categories. The first category is an odd number, and the second category is an even number. Now, what happens, first of all, let me give you an example. So, the basic concept that we have discussed in our classes is that in computer we have several examples of data, right? And can you give me some examples of data?
Text,
Okay. Anything else?
text, images, shapes,
Text, images,
audio, sound.
sounds. Okay. Now, can you just tell me that this data is in this category for me, for computer, what it is considered? For computer, it is always in the form of
Binary.
binary. Okay, perfect. Is always in the form of binary. Now, I need to convey you guys one thing, that if I am sending data from one place to another, my concept is this, that data is always in the form of binary, right? My concept number one. But if your data is being transmitted, if your data is being transmitted from one place to another, is being transmitted from one place to another, do you have any idea that how it is transmitted? What it usually do is that it uses registers to transfer the data from one place to another. And we do have different categories of register. One category could be an 8-bit register, another category could be a 4-bit register, and it even extends up to 12-bit registers and so on. By registers, I basically mean to say that, for example, if it is an 8-bit register, so it's something like 10100011. For example, if it is a 4-bit register, that means 1011. For example, if it is a 12-bit register, that means 111001011110. So basically, these are known as your binary registers, and you use them if you want to send data from one place to another. I have this example, then this is a 4-bit register, and so on, this one as well. So are you clear with it? Do you have any confusions till here?
No, sir.
Mr. Ryan, do you have any confusion still here? Hello, Ryan, are you here? Okay, so now what really happens is that you need to listen to me right here carefully. That, for example, if I am sending data from A to B, so even before the data is sent, it goes into your 8-bit binary registers, like this way. This is an 8-bit binary. Now, what really happens is that you basically need to count the number of ones right here in this binary register. So basically, the number of ones right here are 1, 2, 3, 4, 5, right? The number of ones right here are 5. Now, when the data is received at your B end, so what really happens is that your data is received like this. Now, it is going to count the number of ones again. So for example, if your number of ones are same, for example, 1, 2, 3, 4, 5, that means that your data is accurately transmitted because it was following an odd parity. The number of ones are in odd order and they are same, so it means your data is correctly transmitted. This is your example number 1. Do you have any problems with this?
No, sir.
No.
Now, for example, if you have another 8-bit binary register and this says that your data is this, and when it reaches, it is something like this. So right here, you can see that this is basically 1, 2, 3, 4. Now, the number of ones I have right here is 4. That means that I am working on even parity. But when the data is received, it has 1, 2, 3. It has 3 number of ones. That means that earlier it was odd, but earlier it was even, but when received, it becomes odd. Now, in this example, I can say that data is not accurately transferred, right? Because the number of ones are changed. But similarly, in this example, my data was accurately transferred. So this is it for your example 1 and example 2. So is the main concept, main idea of parity check clear?
Yes, sir.
Clear, sir.
You can also say that parity check, this method is based on the number of ones, right? Like what you usually do is that you are basically counting the number of ones, that either if they are odd or even they are or even if they are is an even number. For example, if it is 1, 3, 5, 7, or if it is 2, 4, 6, 8, 10. So in this example, there is one important point that that says that before your data is transferred, an agreement is made. An agreement is made between your sender and receiver regarding which type of parity is being used, right? That means that at the sending point, if it says that your parity is even, that means when the data is received, it should make sure that the parity is even. That means data is accurately transmitted. However, if the parity at the sending stage was even and when the data was received, it becomes odd, this means your data is not accurately transmitted. That means that even before the data is transferred from one place to another, what you usually do is that they makes an agreement between each other and then at the end they check it. So let's check another example from our course book, that is right here. Now here you can basically see that
Sir.
G.
Sir, what if both are odd, but like the numbers of ones are different?
If both of the numbers are odd, that means your data is accurately transmitted. But that would work if initially it was odd, but when it is received, it becomes even. Then it is not going to work.
Okay, sir.
Now, for making your concept more clear, here is a given example. Now, this says that I have an example of this is the number, and they consider this as your parity bit. Now, in this example, if the byte is using even parity, since this is an 8-bit register and it has 8 bits, so 8 bits is equals to 1 byte. This is why it says that if the byte is using even parity, then the parity bits need to be set to 0. What is the reason? Because 1, 2, 3, 4. Now it is using an even parity. Now what you need to do is that you need to put a 0 here, because this is the only way it becomes an even parity. But just in case if this is an odd parity, then what you need to do is that you need to set a 1 here, because 1, 2, 3, 4, 5, it will become an odd parity. So there could be questions into your exam that ask you that you need to set the number of parity as even or odd. So is it clear to you?
Clear, sir.
Clear, sir.